Let's continue. Section 3. PV Power System. A PV converts solar irradiance to electric power. As you know, a PV power system is clean and it requires no fuel. Moreover, it doesn't need any moving parts, so it is easy for installation, operation, and maintenance. Since 2014, we have been conducting research and development of PV power systems. In this photo, we have a PV panel with a solar irradiance sensor. The panel is connected to a power converter which delivers electric power to the load. During a sunny day, the solar irradiance changes gradually all the day. It rises in the morning, keeps almost constant at noon, and goes down in the afternoon. However, it more often changes drastically and intermittently due to climate change. Such changes put technical challenge because we want to harvest solar power as much as possible when it is available. Therefore, our mission is to maximize power conversion from solar energy to electric power under changing conditions. Firstly, we investigated fundamental characteristics of the PV panel through experiments. Specifically, we were interested to observe the effect of solar irradiance change to the relationship between PV power and PV voltage. Their relationship under solar irradiance of 786 watt per square meter is plotted in this PV curve. In the other PV curve, we see the similar relationship under solar irradiance of 900 watt per square meter. Notice the difference in the maximum power voltage from these two PV curves. From these experimental results, we know that the PV panel has a maximum power point that varies with solar irradiance. We then realized that we can maximize power conversion by controlling the PV voltage. It is to keep the PV power being at the maximum power point under different conditions. Secondly, our solution to realize the maximum power point tracking method is by the use of a power converter. This power converter requires several electronics controllers. One of them deals with maximum power point tracking. We developed a new maximum power point tracking controller, which is an adaptive PI control based on fuzzy logic. It can handle non-linearity and it has fast time response. We implemented this control algorithm into a digital signal processor. Experimental results. This figure shows time history of the PV panel power under intermittent solar irradiance. This figure plots the PV panel power when solar irradiance changed gradually in the first minutes, and then it changed drastically. These experimental results demonstrated that our mission was successfully accomplished. In a large-scale PV power system, several PV panels are configured in a matrix. They are connected in serial and parallel arrays. Some PV panels may be shaded by natural creatures like mountains and trees, or by human creations like towers and buildings, whereas the rest panels get solar irradiance normally. In this case, it is said that the PV power system is under partial shading condition. Next, these experimental results demonstrate relationship between PV power and PV voltage under partial shading condition. Both figures are under the similar solar irradiance, but with different parts of shaded panels. Notice that PV curve has multiple power peaks. This characteristic adds another technical challenge. A different control method is needed. We have found a new method to solve such problems. Finally, there is another crucial issue on PV power systems. Please guess, what is it? Well, you can freely download an article dealing with issue of PV panel exergy from the International Journal of Mechatronics, Electrical Power and Vehicular Technology. Please visit the journal website at www.mevjournal.com. Here is the Digital Object Identifier (DOI) of the article.